be quiet and pay attention. So, before we start, I just like to enter an note call those of us who are attending the class and the lesson. So, just going fast, I'd like to know if Wesley is in class. Wesley. Jeremiah. Nelson. So we can continue. So, just maybe to recap. I want us to recap on the last, of our last lesson. So, somebody, first of all, let me introduce the lesson. So, this is linear and vector analysis. Are we together? Yes. Linear and vector algebra, sorry. Linear and vector algebra, that we're going to learn about matrices today. But before that, I'd like us to recap of the last or the previous lesson. So what were we able to learn in the last lesson? Yes, I want us to participate, all of us to participate. Yeah? Trigonometric ratios, that's a good trial, however, that was in the other class. Yeah, linear and algebra. Yes? Correct. We define matrices. Okay? And you say we define matrices. What's a matrix? Somebody remind us what a matrix is. Definition of a matrix. As you get in, make sure the dog behind you is not. What's a matrix? Yes.
Matrix is an array of numbers.
Can you clap for her? So she said that a matrix is an array a matrix is an array of numbers arranged in rows and columns, and they're also bracketed. Are we together?
Yes.
Yes, good. So, any other thing we learned in our previous class that will help us to catch up with these lessons? Objectives, yes? Types of matrices, correct. Types of matrices, can you help me get, can we get to understand what are the types of matrices in that one? Square matrix, correct. Singular, identity, column matrices, correct. I believe there are several. Now, which get? Just for a light view, I say identity, column, singular. Which one? Square, correct. So there are several other types. These are just but a few. Which get? So just I believe that is a lot for what we are going to do today. So that's a good recap. Which get? So in today's lesson, by the end of the lesson, you, the learner, should be able to define addition and subtraction of matrices. Then secondly, we are going to perform addition and subtraction of matrices. Just those two. So with me, I have got a chart. I was to use it, but I'll use it to explain and then continue. So here, maybe you can just you raise up your hand and tell me what you are able to see. So what are you able to see? You can raise up your hand. This is just observation. I just want you to tell me what you are able to see. Yes?
I can see matrices
Matrix notations. Yes? Order of matrices. This other end. What are you able to see? Just observe, look, and say what you are able to see. Yes?
Addition of matrices.
Addition of matrices. This one at the end. Elements and subtraction. Correct. So this is basically what we are going to talk about today. So I wish I had something to just attach this on the board, but we will continue because I'm going to just repeat that. So we are going to start with learning about addition. Addition of matrices. Now, under addition of matrices, what do you understand by addition of matrices? I believe, sorry. Yes. Okay. One thing, it's not the first time you are interacting with addition. Already before you get this part, you have interacted with the term addition. Yeah? So, with addition, maybe you can tell me what addition means to you. Yes? Correct. And I think he has summarized it all. And he has stated a very good point. Can you clap for it? Do you know the point he has stated? He has stated that for addition of matrices, you have to add, you can only add matrices of the same order. Are you together? Yes. Order. So under this, we are going to learn that order is key. Are you together? Order of matrices is key. When I speak of order, by now we have known that a matrix is an array of numbers arranged in rows and columns. So I'm going to give an example very fast. Assuming you have been given a matrix of this sort, maybe matrix A, would be a square matrix of 1, 2, 3. And we have another matrix B equals to maybe, you are able to see that? And you can be told now to perform addition for these two. So how will you do that? You say that. That's that. So one thing that we'll do, as I told you earlier on, first of all, the first rule is that the matrices must be of the same order. Just look at this order. Which order is this? Yes? These are 2 by 2 matrices, correct? And which one is this other? Yes. 2 by 2, correct? So it is at this point that we are able now to say that the two are compatible and we can do an addition of them. Are we clear? So this is what you need to know about addition. For addition of matrices, you are going to add individual elements of the matrix of matrix A. For example, this element, these are the elements. Are you together? The position is row 1, column 1. So you will add this to the other element in matrix B of the same position. Are you together? That is row 1, column 1. So that is what we are going to replace. I'm going to give just a very fast explanation. So in this case, we'll have 1 plus 5. Right? And then this other one, we'll add it 2 plus 6. This one. And then lastly, 4 plus 8. Right? So with that, we can now analyze that and say 1 plus 5 is 6. This plus that. Right? This plus that. 10. Lastly, 4 plus 8. 12. And as easy as that, we have our answer. Let's get it. I hope that is understood. Anybody having a question related to that? When you're not got? Kosawa? Aye. The next step that I want to work on or tackle before I give you work to do is that is on the second part of our study today, which is now subtraction of matrices. Now we would like to use the same examples that have been given out to solve that. So before that, so what do you understand by subtraction of matrices? Subtraction. That's another term that is not the first time we are interacting with it. We learned it in the previous levels of study. So what is subtraction? And then directing it to matrices. Yes? Correct. Subtraction just as we did addition. This one involves now subtracting elements of a matrix from a matrix that we're using. Yeah. So like the next example I will use is the example I've used there. Example. Now this will be example 2. Okay. Don't worry about this because I want to use this. This was example 1. Single. Maybe I can have this side. So with this example, first we have matrix A and matrix B. And I want to subtract, assuming you have been given maybe A minus B. How will you solve that? I'd like someone to come and do it for us. As I've told you, in this case we are adding, but in that other case we'll be subtracting. And before somebody comes over to the board, there's one thing you have to note for that is taking you back to addition, so that you know what you're going to do now in subtraction. In addition, is that addition of matrices is commutative. What does that mean? Yes. Correct. Wonderful. Clap for him. That is what that simply means. Are you together? However, now in subtraction, we are going to learn that it is now the vice versa. In subtraction of matrices. Wow. Maybe a minute has to be a minute. So just to conclude, I think 2 minutes. Yeah. Right. Okay, very fast. Just as I said on this addition, they are commutative, while in subtraction, they are non-commutative, meaning this one does not mean this is not equals to now b minus a. No, not equal, yeah, not equal. That cancel slash that. And I think with that, maybe because of time, we won't be able to maybe do a lot, but there's work that is given for you, and I think that is in page 600 of the book you're using, JPAD. Are we together? You get an exercise there, and you are able to you'll be able to do it. Also, we'll engage much using the Teams so that we work. You will be able to find more resources in the Teams class group. Are we together? In Teams. That's all. And I believe, are there any questions? Any questions?